Hi, I'm Mr. V. This is Illustrative Mathematics, Unit 5, Solid Geometry, and we're on Lesson 9, Cylinder Volume. The objective is, by the end of the class, you should be able to say, I can calculate the volumes of solids that are composed of cylinders. And I can explain how to find the volume of a prism relates to finding the volume of a cylinder. So we start off with, here are two objects, two solids. One is a cylinder and one is a right rectangular prism. What information would you need to calculate the volume of each? And what is the same or different about how you would find each one of them? And I'm going to point out to you that and you should try all of these problems, today's exercises, on your own before watching the video, and then watch it if you want to see what I've done, because I'm going to work through these problems. Here, if I have the base of this, and I can draw the base of this one too, and here. So the volume of a cylinder is equal to the area of the base, and I use a capital B to talk about the area of this base, times its height. The area of this right rectangular prism is equal to the area of the base times its height. Now, what differs here is that this has a radius, and the area of this base is equal to the area of a circle, so it's pi r squared. And here we have the area of this. This has length, width, and height. So the area of this base is the length times the width. What do they have in common? They have an area of a base and they have a height. What do they have that's different? Well, this has a radius. This has length and a width. They're similar to each other. The question I ask is a cylinder a prism? And one person said, well, this has a top and a bottom that are the same. This has a top and a bottom that are the same, so that it has to be a prism. Another person said, well, this is not a polygon for the base, so it can't be a prism. And actually, the answer is no, a cylinder is not technically a prism. However, if you think of it as having infinite sides on a polygon, it behaves like a prism does. So it has a lot of similar qualities, but technically it is not a prism. Now we have the water transfer. Here we have, what does it say? It says in previous grades, you learned to calculate the volume of a cylinder. The volume of a cylinder is pi r squared times h. And we're going to revisit that process here. Here you're asked to explain your reasoning using complete sentences. So we have two containers. The measurements are in centimeters. Suppose the prism, this one, contains water that reaches a height of 1 centimeter. On the figure, draw a representation of this. And then that water is poured into the cylinder on the left. And what height does it go to? So if we look at this problem, I'm going to draw in black the rest of the cylinder and the rest of the prism. This is a dotted line. I'll draw in blue the level of the water. So the water comes up to here, 1 inch, and it's going to go dot, 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 dot. So this is height is equal to 1. And here we don't know what the height is going to be, but we're going to have it go around like this and somewhere around. So how high does it go? Well, the volume of the right rectangular prism is equal to the area of the base times the height. That's equal to length times width times height. I'll write the formula. I'll substitute the values, and then I'll solve. So I have 4 pi times 9 times 1, which is 36 pi. Now we dump this volume into this guy. Here we don't know what the height is. We're going to look for height. We know that the radius is 6. So volume is equal to the area of the base times the height, which would be equal to pi r squared times the height. We know the volume because we're pouring the water into it. The water we're pouring into it is 36 pi, and that's equal to pi times 6 squared times my height. Well, this is 36 pi. My height has to equal to 1. What if I did it with 3 inches? Well, how would you find it with 3 inches? What if it was 9 inches? What if it was 4.5 inches of water that we have that we're dumping into the other? What I want to point out to you is if I think of this as the volume is equal to the area of the base times the height, volume is equal to the area of the base times the height, notice this has an area of pi r squared, which is pi times 6 squared, which is 36 pi. Here we have an area of the base, which is the length times the width, which is 4 pi times 9, which is 36 pi. They're the same. Since these bases are the same, when I multiply it by the height, my heights would have the same level. They would rise to the same level. And that's what we explore in this activity. So the goal of this is to make certain connections between methods of calculating volumes for prisms and cylinders. And I'm asking for some of your reasoning. Consider the formula of volume is equal to base times height, for example. And how would you describe the volume of two containers that compare? Describe any other solids that have the same volume as these two. We have here rotations or visiting rotations. Remember us doing a rotation here? Sketch this and then find its volume. So if I sketch this when it's rotated, around the top, I'm going to go 2 this way and 2 this way. Around here, I'll go 2 this way, and then it's going to go dash, dash, dash. Here, I'm going to go 5, 1, 2, 3, 4, 5, and I'll be able to see the whole top up to this point. Then it's dash, 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 like this. And around the bottom, we'll be able to see the bottom all the way up to here, and then it's going to be dashed. So you can see I've got 2 cylinders, and I'm going to add them together. The volume of the one cylinder is equal to the base times the height, the area of the base times the height. The volume of the second cylinder is equal to the volume of the area of the base, capital B, times the height. The area of the base is pi r squared, r is 2. So this is pi times 2 squared, and my height is 3. Here we have the base is pi times the radius squared, which is 5 squared, and my height is 3. So when I have 4 times 3 is 12, that's 12 pi. I'm adding these together. Plus here we have 25 times 3, 3/4 is 75 pi. I end up with 85 pi. And if I want, 87 pi. And if I wanted to get a decimal approximation for this, I could plug this into a calculator. But this is going to be my answer. It's going to be in centimeters cubed. Okay. The same thing for this one. Here, we go around 3, come back around 3. I'll go around 5, come back around 5. Down below, we'll go around 3, come around 3. I can't see that, so I'm going to put a dotted line there. I'll go down 5 and come back around 5. And I don't know if you can see this or visualize it, but I've got the one cylinder on the middle, and I've got the bigger cylinder on the outside. And if I take the one on the outside and subtract the one on the middle, that will give me my answer. Okay. Well, the volume of a cylinder is equal to the area of the base times the height, and that's what's true for the one or the other. So for the volume of 1, which is the big one, I'm going to have pi r squared, 5 squared, times the height, which is 1, 2, 3, 4, 5, 6. For the volume of the smaller one, I'm going to have pi times the r squared, which is 3 squared, times 6. So here I have 25 times 6, let's see, 6/4, that's 150 pi. And I subtract from it my 3, which is 9 times 6, which is 54 pi. And I get for my answer 96 pi. And again, you can plug that into a calculator if you want. That brings us to this page, revisiting rotation. Given a cylinder with radius r and height h, write an expression for the volume if these changes were made. If the height were tripled to be 3h and the radius remains the same, if the radius was tripled and the height remains the same, and then given the cube of side s, what happens if we triple the sides of it? Which of these changes is the most? And so let's do this. If we start with a cylinder, here we go, cylinder, And the first thing we're going to do is we're going to take the height, and we're going to triple it. So the volume of this is equal to the area of the base. It's equal to pi r squared. I'm going to put that down. Pi r squared times h. And we're going to triple this. So my new volume, my second one, is going to be pi r squared times 3h. And it would look like this. Here's my 1. This is 1 height, 2 heights, 3 heights. So it's going to look like this. On the second one, we have this cylinder. Here's my radius. And we're going to triple the radius. So 1, 2, 3, to get to a larger cylinder. So I go from my original right here. I'm going to take my original, pi r squared, h, and we're going to triple the radius. So we have volume is equal to pi times 3r squared times h, because this is my radius now. It's 3r. And what you end up with is 9 times larger. Instead of just being 3 times larger, I've got 9 times larger. Pi r squared h. If I have a cube, a unit cube like this, and I were to triple its length, width, and height, so here I'm tripling the length, triple the width, and I'll also triple the height. Go 1, 2, 3 times as high. Notice I'm going to mark this down. So it's 3 times as high. And if I were to draw it across the top, how many times larger? How many blocks are there going to be for here? So my original block is equal to some volume. It's equal to the length times the width times the height. And if I triple the length, triple the width, and I triple the height, it's going to be 27 times larger than the original. Wow. So this would definitely have the biggest effect. Notice, because I'm squaring the r, this one's going to be bigger than this one, not the same. And the lesson synthesis. Here's some objects. Which one could be used? This formula, volume is equal to area of the base times the height. Of course, a cylinder, a rectangular prism, another type of prism, a hexagonal prism. Pyramid, no. Ball, no. Cone, no. And for the cool-down, there's this cool-down activity for you to try. And you were supposed to upload a picture of it, which is how you do that. And there's just some explanations on how to do that. And that's all that I've got for you today. So good luck and success.